All right, let's do this one. So it's actually a decay series, right? Americium from the previous problem will decay to, is this neptunium or something like that? All right, so let's figure out this decay. The left side is 243.061373, right? And then we're going to subtract. Let's add these guys together. So 239.052932 plus, and then remember we look up, this is a neutral helium atom, right? So plus 4.002603. The right side is 243.0, oh, this is cool, 55535. All right, are we ready for this? So 243.0.061 373 minus the answer I just got is 0.005838 atomic mass units, again multiplied by 931.5, because every atomic mass unit is this many MeV. Right, so times 931.5, and I get 5.438 MeV, right? Okay, so what is the velocity of this alpha particle? Well, let's assume that the alpha particle gets all of that kinetic energy. So here's our mass, right? I think this is not going to give us a relativistic velocity. So let's turn this MeVs into joules. So 5.438 times 10 to the 6th eV, right? Remember, it's mega electron volts times 1.602 10 to the minus 19th. This is joules per eV. So this answer I got, E6 times 1.602 E minus 19 is, this is actually equal to 8.7118 times 10 to the minus 13th joules. That's not very much. And then I'm going to use what energy is 1/2 mv squared, right? Right, so 8.7118 times 10 to the minus 13th is equal to 1/2, and then the mass of an alpha particle. This alpha particle, by the way, has a little bit more mass because it's carrying this energy, but let's ignore that. 6.64 times 10 to the minus 27. It's not a huge amount. And then v squared, right? Okay, so I'm going to multiply the number on my calculator by 2. Divide by 6.64 E minus 27. I've got v squared and I'm going to square root. And I get a very unhelpful number, 1619896 meters per second. Let's see, what is that? Okay, so it's 1.62 times 10 to the 7th meters per second. Now we're good with this velocity. This is great. This is what, 5% of the speed of light or something like that. Let's see, divided by 3 E8. Yeah, it's about 5% of the speed of light. 5% is great, 10% is great, 20% is getting a little dodgy. By the time you get to half the speed of light, remember the speed of light's 3 times 10 to the 8th meters per second. By the time you get to like a third the speed of light or half the speed of light, you'll be off significantly, like 20%. And the reason that you can't use this formula is that this mass does not stay constant. Okay, and we'll look at the end of the year, we'll look at how you actually calculate relativistic kinetic energies. And it's not hard, you just have to take into account the mass.